JavaScript is a single-threaded programming language. That means it can run only one piece of code at a time in a single sequence. But even with just one thread, it's powerful, thanks to the event loop. Let's briefly talk about execution context and call stack. When a JavaScript function is called, it creates an execution context. This context is pushed onto the call stack, which follows a last in first out model. JavaScript runs the code at the top of the stack, finishes it, and pops it off before moving on. But before we are going to code, let's talk about event loop and setTimeout. What happens when a function schedules an async task like setTimeout? A function takes some time to execute. That function is handed off to the web APIs and placed in a separate queue. Once the call stack is empty, the event loop brings that task back and executes it. This is how JavaScript feels asynchronous without blocking the main thread. Let's build a short utility function and see all of this in action. We begin with the main function, account_data_util. It logs that it has started, calls another function named account_data, and then logs that it has ended. This simulates a high-level workflow like initializing a user data on login. Next, let's define the account data function. It starts by logging that account data has been initiated. Then it calls enable profile settings, which is a simple synchronous function. Finally, we schedule a task using setTimeout to simulate something like showing a promotion banner after the rest of the UI is loaded. This task is asynchronous. It's deferred until the current call stack is clear. So the console output that we are expecting will be something like this. The first 4 logs come from synchronous functions. Executed in the order they are returned. The final message, enable promotion banner, appears after the call stack is empty. That is the event loop bringing in our setTimeout callback from the queue. So this is how JavaScript, even though it runs on a single thread, manages to handle both synchronous and asynchronous task operations smoothly. It's all thanks to the execution context, call stack, web API, and the event loop. Understanding this flow is a key to mastering modern JavaScript. We will trace what happens line by line and how each part of the system interacts. The script begins by calling main, which will be the first execution context comes to the call stack. Inside main, we invoke user data fetch. This function creates a new execution context, which is pushed to the call stack. The first line inside user data fetch is a console log. So user data fetching started is printed immediately. This is synchronous, so it's executed right inside the call stack. Next, we hit setTimeout. This is not handled by JavaScript directly. Instead, it's passed to the native APIs. The next line, user data load complete, is also synchronous, so it's immediately printed after the timeout is scheduled. The timer begins and the callback function is registered to be executed after 2 seconds. It's not added to the call stack yet. It is scheduled into the macro task queue. Once the 2-second timer ends, the event loop checks if the call stack is empty or not. It finds the callback in the micro task queue and moves it into the call stack. Then the message user data loaded is logged. This entire process involving the call stack, native APIs, macro task queue, and event loop is what lets JavaScript remain non-blocking and responsive, even though it's single-threaded.